This is lesson 6-2. It's analyzing reflections on page 316 to 318 of your workbook. Example 1 starts on page 316 and it says, the client also wants the architect to flip the placement of the grill, putting it on the other side of the patio. Where does the client want the grill to be placed? So, when you want to flip something to another side, that is a reflection. So we're going to flip this grill to the other side, which means that we are going to need a line of reflection. You're going to think about that as your mirror line, over which we are going to reflect something to the other side. Now, here's something that's really important, and kids sometimes get confused. Just because it's on the other side and it looks like a mirror image does not mean it's a reflection unless both figures are the same distance from the line of reflection. So let me give you an example of what I'm talking about. So let's say that we have this triangle and this line of reflection, and I put it all the way over there. This distance and this distance are not the same, so that is not a pure reflection. It is actually a reflection and a translation. So for something to be a reflection, this distance and this distance needs to be the same. Now let's see if I can do this. Something like that. I might have had that backwards. Sorry, I'm not very good at drawing. The point is that your distances have to be equivalent or you do not have a pure reflection. So here we've seen that our grill has been reflected. You're going to notice that it's the same distance from the line of reflection as it used to be. That's important. The grill has the same size and shape, which makes it congruent. The only thing that's different is the orientation or the direction has changed. The angles are all the same. The side lengths are all the same. Everything's the same except for how it's facing. This is the try it on the bottom of page 316. While updating the design, the architect accidentally clicked on the chair and reflected it across the center line. Draw the new location of the chair on the plan. All right, I'm going to attempt this. Be kind about my drawing. Whoops, I already started off with a highlighter, not a pen. Okay, let's try this again. So this is the big blue square. And here's the chair. And here is our center line. So I want this chair to be the same distance as it used to be to the line of reflection, just on the other side. So let's put the chair over here. Now do your best to make sure your chair is the same size and shape. The only difference is it is exactly the same distance, but on the opposite side of your line of reflection. We are on example number 2 on page 317, and there are going to be times when you are going to have to draw the reflection on a piece of graph paper. And so we have some important information here. We have a polygon, A, B, C, D. We have where the vertices are. Vertices are simply the corners. So the first thing they did was they graphed A, B, C, and D. And as a little refresher to your graphing, remember in an ordered pair, your X number is your side-to-side number and your Y number is your up and down. So when they graphed -5, 2, they went over to -5 and then up to 2. All right, so they graphed all of their corners, and then we're going to do a reflection. Oops, let me change that to a highlighter. We're going to do a reflection across the x-axis. So let's figure out where the x-axis is. It's this side-to-side one. So I'm going to flip it over this line of reflection. And the only thing you have to remember is it is not going to sway side to side. It's simply, in this case, going to move top to bottom. So if A is 2 spots above the line of reflection, A prime will be 2 spots below the line of reflection. Similarly, if point D is 5 points above the line of reflection, D prime will be 5 points below the line of reflection. And so what they did was they took all of those points and they put them the exact same distance from the line of reflection, but on the opposite side, and they connected their dots, and voila, you've made a reflection. This is the triad on example number 2. Quadrilateral KLMN has these vertices, K, L, M, and N. It is reflected across the y-axis, which, if we're thinking about that, that's this one, that's the up and down one, resulting in quadrilateral K prime, L prime, M prime, M prime. What are the coordinates of point N prime? Now, I'm glad that we read that all the way through because I don't have graph paper, and so I was a little worried about how I was planning on graphing all of that, but really all I have to figure out is N. So I'm going to go ahead and look at N is right here. I'm going to go over 3 and up 2. I'm going to say N is about right there. I need to flip it over this axis. So it is not going to shift up and down. It is simply going to shift left and right. And if you remember, I was 3 away from the axis. So I need to stay 3 away from the axis. And I am not moving up or down. So N prime is right there. And it looks like I'm over -3 and up 2. Those are the coordinates of N prime. We are on example 3 on page 317. So example 2 was you have to draw it. And example 3 is it's already drawn. Can you figure out how it got there? So this one says, what is the rule that describes the reflection that maps parallelogram ABCD onto parallelogram A prime, B prime, C prime, D prime? Okay, so what I'm looking for is a line that will go down through the center and be equidistant. Ooh, look at me using my math vocabulary. From both vertices. So I'm going to start where it looks like they're closest. So it looks like they're closest right here. And so I want to draw a line down through the center that would make it D and D prime equidistant from that line. Now I'm going to check all the rest of them. A and A prime are the same distance. B and B prime are the same distance. C and C prime are the same distance. So it looks as if I reflected over the y-axis. Right here, this is an important piece of information you might want to highlight. When reflecting across the y-axis, the y-coordinate remains the same, and that's because we're not going up and down. The x-coordinate is the opposite because we're flipping from left to right or right to left. We are on the triad on the bottom of page 317. Polygon ABCD is reflected across the line x equals -2. We're going to talk about that. Graph and label the image, and then we'll talk about the angles. Okay, so when you have x equals -2, that is every time that x is -2. And x is -2 here, and here, and here, and here. In fact, x is -2 in all of those places. Now I've got my line of reflection. And I'm going to start with C just because it's kind of close. C is 1 to the left of my line. C prime is going to be 1 to the right of my line. Let's go to B. B is 1 to the left of the line of reflection. B prime will be 1 to the right of my line of reflection. Notice I'm not moving up and down. I'm just going side to side. A was 2 to the left of the line of reflection. A prime will be 2 to the right. E was 1, 2, 3 spaces from the line of reflection. So E prime will be 1, 2, 3 spaces from the line of reflection. D is 1, 2, 3 from the line. So D prime will be 1, 2, 3 from the line. Okay. I'm going to connect my dots with a dark color, I think. All right, here they go. Connect the dots. And I have done it. I have my image. So on this one, because I'm not changing the size or the shape, I'm getting a congruent figure, which means all of my angles have got to be the same. So reflections can create congruent figures, and all the corresponding parts are equivalent. The line segments are the same length. The angles are the same measurement. This is your key concept on the top of page 318. And it says a reflection, you might have called that a flip when you were a little person, is a transformation that flips a figure across a line of reflection. But you have to be very careful. A pure reflection, all of the vertices will be the same distance from the line of reflection, but on opposite sides. Everything is the same. Side lengths are the same. Angles are the same. We have congruent figures. They just happen to be on the opposite side of a line of reflection.